Using OpenStax textbook Calculus Volume 2, we're in section 3.1, and we're talking about techniques of integration. We worked with integration by parts in the video before this. This example is going to require us to use parts more than once. So we're going to start off looking at the problem as, sorry, my pens were not out. U is going to be sine ln x and dv is going to be dx. So when we take du, the derivative of sine is cosine, keep your ln x, times the derivative of ln x, which is 1 over x dx. When we integrate dv, we get v equals x. So now we have u times v minus the integral of v du. Okay, and if we simplify, the x and the 1 over x are going to cancel. So we have sine ln x times x minus the integral of cosine ln x dx. This time, u is going to be cosine ln x, and dv is going to be dx again. So v is x, du is negative sine ln x times 1 over x dx. All right, so we still have this x sine ln x minus my new u is cosine ln x. My new v is x. I'm going to put it in front like this. Minus the integral of v du once again, 1 over x and x simplify. We have x sine ln x minus x cosine ln x. This minus, when it distributes, makes this a plus the integral of negative sine ln x dx. Well, we are going to rewrite our problem as the integral of sine ln x dx equals x sine ln x minus cosine ln x, x cosine ln x minus, because of this coming out, the integral of sine ln x dx. So you should notice that my original has come back here in the end. So what we'll do to solve this is we will add the original to both sides. Which is what you do when the original comes back up. So we have 2 times the integral of sine ln x dx equals x sine ln x minus x cosine ln x. To get my integral by itself over here, I'm going to divide both sides of the equation by 2. Got to move over. So we're going to have the integral of sine ln x dx equals x sine ln x minus x cosine ln x all over 2.